This is A-level mathematics. We're going to be doing chapter 6, differentiating trigonomic functions, and I have a trick to this. So I have a circle here, and for doing derivatives, it's going to go in the order. It goes from sine to cosine, cosine it goes to negative sine it goes to negative cosine it goes back to sine, and it keeps going like that. Now, antiderivative or integral, where it actually go in the opposite direction. So if it goes from cosine, it goes to sine to negative cosine. I have a typo here. So negative cosine. So sine to negative cosine to negative sine back to cosine. So this thing is actually very, very helpful to actually go through and do your integration and your derivatives for all this. This is the way I try and memorize it. Instead of trying to memorize just one to another, you just keep going in a circle. I write it out and then go from there. Alright, so let's take a look at a problem that we're going to have right here. I'll keep this in view. We're differentiating with respect to x. So right here we're going to have chain rule here. So derivative of the inside. So derivative of the inside is going to be 3 times derivative of the outside. So the derivative of sine is going to be cosine times cosine of everything I have in there. 3x minus pi over 4. So my final answer comes 3 cosine 3x minus pi over 4. Okay, so now let's take a look at this next one on B. Cosine to the 4th power x. First thing I'm going to do, I'm going to start with the outside. So the outside. So if I take it, treat this like if it's just x to the 4th. Okay, just right here, if it's only this right here is an x, so it's going to be take the derivative of that. So it's going to be 4, because it goes out front, cosine 3x times derivative of the inside, which is derivative of cosine. So right here, derivative of the cosine is going to give me negative sine. So it's going to be times negative sine of x. Okay, and so right here, we're going to come up with negative 4 cosine cubed x sine x. So one way that is actually helpful whenever you see something like this, you're uncertain about it. Another way of writing this would be cosine of x all to the 3rd power out here. So that's another way of writing this, and sometimes it helps people out when you're trying to do your derivatives. You think of all of this as what's on the inside and then go to the outside from there. So the derivative of the inside is just the cosine x. So maybe that might be helpful on this. Okay, so now let's take a look at C. Now, we're going to take the derivative of this. So first thing I'm going to do, I'm going to rewrite it. We know that secant is going to be 1 over cosine. So I'm going to rewrite this as 1 over cosine x, and I'm going to rewrite that as cosine x to negative 1. So once I go ahead and do that and write it to the negative 1, now I can go ahead and take the derivative. So let's start with the derivative of the outside. So it's going to give me negative 1 times the, let me see, that's going to be cosine x raised to the, that's going to become a negative 2 because I take away 1. Cosine looking pretty ugly there. Alright, so I get this here, and now I go with the inside. So the derivative of cosine is just going to give me times negative sine x. Now if I were to put that together, my two negatives together over here, it's going to make it a positive, so I'm going to rewrite this over here. So I have sine x, which is this one right here, because that one and that one made it positive. And with my negative exponent, I'm going to put it back down to the denominator over cosine squared x. Now, with this one right here, we're going to come up with a couple different identities for my answers on this one. So, I could rewrite this. I could rewrite this here as 1 over cosine x times sine x over cosine x. Sine over cosine is going to give me tangent. This one's going to give me 1 over cosine is my secant. So I'm going to have secant x tangent x. So this comes out to be an identity for secant x all the time. So my derivative for secant x is always going to be secant x tangent x. Now, there's a couple of different ways we could have rewritten this again. So if I'm going to rewrite this, I could rewrite it just in terms of sine and cosine. So it's going to be sine x. And now if I were to break it up, over 1 times 1 over cosine squared x, that could be the same thing as saying sine x, and this is going to be secant, SEC squared x. So this is another way of writing this. And let's take a look. One more way of writing this is if I go with just rewriting what I had right up here. I'm going to write that as, let me see, 1 over cosine x times sine x over cosine x. So 1 over cosine, I'm going to leave it in the denominator for this case right here because I've already taken it up and got that one right there. But sine over cosine is going to be a tangent. So I'm going to have tangent x over, since I'm leaving cosine in the denominator, that's going to be a cosine x right there. So now, out of this one derivative here, I have 3 separate answers. Now the common one that we're going to use is this one right here, because this is going to be my identity. So whenever you see secant x, the derivative of that, we're probably going to use this one almost every single time. Alright, this next part, 6.3.2, we're going to find the derivative of ln secant x. So first thing we're going to do, we're going to take the derivative of the inside. So the derivative of this, I'm going to use the identity that I just made. So it's going to be secant x tangent x times the derivative of the outside. So now think of this as just all one thing right here. If this was just x by itself, so the derivative of ln of whatever I have there is going to be 1 over secant x. So we're just taking the derivative of that with respects to this inside here. Now when I have this one right here, I could see that I have a secant x here and I have a secant x down here. So together, that's just going to give me, for my final result, a tangent x. Now on this next problem right here, we're going to find the minima and maxima of this equation. 6.3.4. So first thing I'm going to do, let's find the first derivative. So first derivative of that, so is going to be, let's see, this is going to give me 4. Now derivative of cosine is negative sine, so that's a negative 4 sine of x. Now again right here. Now derivative of the inside of all of this, I'll put parentheses around this to make it a little bit clearer. So the derivative of 2x is just going to be 2. So I'm going to have a 2 there. And the derivative of cosine is negative sine, so that makes it a minus 2 sine of 2x. So now I have the first derivative, but I can't really do much of anything with it because I have a single angle and a double angle together. So I need to go ahead and make that other one into a single angle. So let's take a look. I have an identity for this one right here. So if you go back, I believe it was last chapter, where we have the double angle for this, that I'm going to replace this. So I have the identities that looks like this. It says sine 2a is equal to 2 sine a cosine a. So that's the identity there. So I'm going to replace that, just this part right here, and so with this. So I have negative 4 sine x. Now because this one has a 2 in front of it and I already have a 2 in front of this, it's going to make it a negative 4 sine a. It's not a, it's x's. These were x's right here, sorry. X's. I was copying it down from the identity. Alright, so sine x cosine x, because these are in terms of x, not in terms of a like my identity had. Okay, so now from right there I'm going to do a little bit of factoring. So I have, let's take out a negative 4 sine x, and I'm going to have 1 plus cosine x. And this is all my first derivative. So that's my first derivative there. Now, from there, to find my minima and maxima, I need to first start by setting my first derivative equal to 0. So when I set this equal to 0, it's factored already, so it's going to be 0 equals, so now this part right here, negative 4 sine x divided by negative 4, so I should get 0 is equal to sine x. Now, on a unit circle, right here, where is sine going to be equal to 0? I brought mine with me. So right here, sine equals 0, it's going to be between, so I got 0 pi here, and I also have at pi right here. So at 0 pi and at pi. So now for this problem right here, we need to look at the problem and see what my interval is. I didn't write it down. Bad me. Okay, my interval is going to be 0 less than equal to x less than, it's not equal to. So just less than 2 pi. So that means that it can't be equal to 2 pi. So it could be equal to 0, but it cannot be equal to 2 pi. So now right here, so in between all of that, I'm going to have, this is going to be a 0, and this one's also, this is going to be pi right here. So that both places it's allowed to be 0. I'll have sine equals 0. Now let's do the second part right here, the 1 plus cosine x. So if I get 0 equals 1 plus cosine x, okay, subtract it from both sides, and I should get, let's see, negative 1 equals cosine x. Now there's only one place where cosine is going to be equal to negative 1. So cosine is the x value, so it's going to be right here. So the cosine is going to be So at pi, cosine is -1. So this one's going to be pi. So I have multiple places, multiple answers. So I have 3 answers for this one right here. So for this one I have 0 and pi, and this one I have pi. So when I plug it back in, I'm only going to have to use 0 and pi. I don't have to do it twice. But I got 2 answers, but 3 different places. Okay, so now I have that equals 0. So now we need to go through and do the second derivative. So I got my first derivative. I'm going to rewrite my first derivative here. -4 sine x minus 2 sine 2x. Take the derivative here. So right here, the derivative of negative sign is going to give me cosine, even though it's a negative sign out here. So negative sign is negative cosine, so it's this, I get second derivative is going to be -4 cosine x. Now right here, now derivative of this is going to be give me 2, so that's going to make this one be 4. Derivative of negative sign is negative cosine, so I right there cosine 2x. Okay, so now let's see what we get here. So now I know that we're equal to 0 here and here. So where, let's take a look and plug this in here. If I plug this in here, I get that for 0, sine at 0, cosine at 0, sorry. Cosine at 0, here's 0, 0 pi. Cosine at 0 is 1. So right here I'm going to have 1 times -4, -4. Right here, this is also going to be 1 times 2. Wait, 0. I'm plugging in 0 here. Okay, 0 times 2 is 0. Cosine of 0, okay, it's 1. So I'm going to have -4. So when I plug in 0 for this, I get -8. So because I got -8 here, now that means that my first derivative is going to be greater than my second derivative. So right here I have that my, let me see, how did I write that on my rules? I believe it was like, is less than, there it is. So that means I have a maximum at 0. So at 0, when I plugged in 0, that's going to be my maximum value. Now let's do the same thing for my other value, my pi. So let's take a look. I'm going to plug in. So f pi, here it is right here. So cosine at pi, so from a unit circle, so cosine at pi is -1. So I'm going to have -1 here times -4 is going to give me a +4. Now right here, when I plug in pi, I'm going to get 2 pi. Cosine at 2 pi, here's my 2 pi, is going to be a +1. So now I have a +1 times -4, -4, and so that's going to give me pi 0. Ouch, I got some issues on this one. Now because my rules are that we have f double is greater, we get a min, and f double less than, we get a max. But right here, there's no equal sign here, so it doesn't. So we need to try and figure out what this one's supposed to be, because it doesn't say what happens when it equals 0. So now I need to look at a couple things. First thing I have to look at is right here, my first derivative. What is it going to be right here? What is it going to be for this one? Looking at my first derivative, so in my interval from here to here, right here in between 0 and 2 pi, I know that 0 is one of my points. So what I'm going to do is I'm going to break it up into two different parts. So first part is going to be 0 to pi. And we're going to pick a number in between, and we're going to see what our value is there. Is it going to be positive or negative? We'll see. Okay, so let's take a look. I'm going to have, I'm going to pick pi over 2. So of pi over 2. The reason why I picked pi over 2, because it's going to be nice and pretty, because I get either a 0 or a 1. So it's going to be easy to actually input that. I know it's going to be between 0 pi and pi. So right in the middle, so it's going to make it easy to plug this in. So now let's go ahead and plug that in, and I'm going to get equals -4. Now sine at pi over 2, so I'm looking off this one right here. Sine at pi over 2 is going to be 1, and the next one's going to be -2. Now the next one says 2 times, right here, if I'm plugging in here, 2 times pi over 2 is just going to give me pi. The sine value at pi, right here, here's pi. Sine value at pi is going to give me 0. So that whole thing is going to give me 0 there. So I get f prime pi over 2 is, that becomes 0, and I come up with -4. So that one's going to be negative. So that one's negative there. It's fine. Now let's take a look at the other one, because we already took care of that a minute ago when I had the negative. Now let's see if we can get in the other interval. My other interval I'm going to use is going to be from pi x, and we're going to go to 2 pi. So I started here from 0 to pi and got that part, the negative part already, and now I'm going to try this part right here and see what I get right here. So negative, we've already decided that this is going to be less than, so that means that I'm going to have the max on that one. Now this one right here, I'm going to have, let's take a look, let's plug in. So I'm going to use that's the first right there, of 3 pi over 2. The reason why I'm going to use 3 pi over 2, because if you notice in between pi and 2 pi, 3 pi over 2 is going to be nice and pretty. I get a 0 and -1. So those are going to be easy to plug in. So I have -4. Now sine at 3 pi over 2, sine is going to give me -1 minus 2. Now let's see. So if I plug in 3 pi over 2 for this one right here, 3 pi over 2, the 2's cancel, so I'm left with 3 pi. Now sine at 3 pi. Let's take a look at my unit circle again. Right here, I'm going to go 0, 1, 2, back to 3. So 3 pi, sine is 0. So sine right there is going to be 0. So together I'm going to have f of 3 pi over 2 is going to give me a positive 4. Now this one's going to be greater, so that means that this is going to be my minimum. So for this and this, we did all this one right here because of that right there. Because I don't have anything stating about if it's going to be minimum or maximum at this point right here. But because over here I ended up with a positive, this one's going to be greater, so that means that this one right here is going to be my minimum. So I have a minimum at pi. So at pi. At pi you get a minimum, and at right here, where do we come up with 0, we had a max. So that took care of my minimum and my maximum for both of those. So the reason why I had both minimum and maximum on this, because when I went through and factored it out, I came up with multiple answers. That's why I ended up with both. Previously on the problems that we've done before, we've only had one answer, and that one answer is either going to be the minimum or the maximum, and that's what we came up with here. Alright, so our practice, okay, page 88, 2 through 6, 8 through 9, 13 and 19. Now the homework, let's see if we could see this pretty well. We have 2 D, F, G, K, 3 E, F, G, L, 4 AE, 5 BD, 6 ABC, 8B, 9D, and number 19. So this is a larger homework assignment, but there is a whole bunch of different types of problems that we did cover this time.